And now in this lecture we'll find out the radius of a circle. In the drawing we have the right triangle, triangle ABC. Angle ABC equals to 90 degrees in its size. And inside this triangle ABC, the right triangle ABC, we have this circle. And our mission is to find out the radius of this circle. In addition, we know that this is line segment AS that is equals to 1 unit in its length. This is line segment ST that is equals to 3 units in its length. And this line segment TC is equals to 2 times square root of units. 2 times square root of 3 units in its length. And again, our mission is to find out the radius of this circle. So first of all, we define the center of this circle, this point as O. And we define the radius of this circle, the radius that we are looking for, as x. So the radius of this circle is equals to x according to our definition. In the next step, we'll join points O and Q together by a straight line. So what is the definition of line segment OQ? Line segment OQ starts from point O, that is the center of the circle, and ends at point Q, that is the point of the circle itself. This is exactly the definition of a radius. Therefore OQ is the radius of this circle, that is equal to x according to our definition. You can implement rule 1. Repeat quickly on rule 1. According to rule 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So in the drawing we have a circle, and we have this is tangent AB, that is tangent to this circle. Here it's point M. Point M is the point of tendency of tangent AB with this circle, and we have the radius OM that is drawn to point M, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, then the radius the tangent AB will be perpendicular to the radius MO. Again, whenever you have a radius that is drawn to the point of tendency, then the radius the tangent AB will be perpendicular to the radius MO. If AB is perpendicular to MO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to this rule 1. We can implement rule 1 in our drawing. In our drawing, we have the radius OQ. We have the radius OQ that is drawn to point Q, that is the point of tendency of tangent BC with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent BC will be perpendicular to the radius QO. If BC is perpendicular to QO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. Likewise, we join points O and P together by a straight line. Line segment OP is the radius of this circle, that is equal to x according to our definition. We have the radius OP that is drawn to point P, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius PO. If AB is perpendicular to PO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. In the quadrilateral POBQ, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, so 270 degrees plus the size of this fourth missing angle. In total, the sum of those 4 angles must be equal to 360 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, this missing fourth angle must be equal to 90 degrees in its size. Again, in order to complete the sum of the angles inside quadrilateral POBQ to 360 degrees, the missing angle must be equal to 90 degrees in its size. So inside the quadrilateral POBQ, we have 4 right angles, and any quadrilateral that has 4 right angles must be at least a rectangle if not a square. So we relate to this quadrilateral POBQ is a rectangle. And we also know that the opposite sides of a rectangle are equal to each other. So in rectangle POBQ, side PO must be equal to the opposite side B. Side PO must be equal to the opposite side BQ. But PO equals to X, therefore BQ must be also equal to X. Likewise, in the same rectangle POBQ, side OQ must be equal to the opposite side PB. But OQ equals to X, therefore PB must be also equal to X units in its length. In conclusion, we found out actually that quadrilateral POBQ is not a rectangle but a square. Why? Because of the fact that all of its sides are equal to each other. In the next step, we define the length of this line segment AP as A. And we define the length of this line segment QC as B. Here we can implement rule 10. I'll repeat quickly on rule 10. According to rule 10 is true in any circle. So in any circle, if AB is any chord, here we have chord AB in the circle, and we have tangent PT that is tangent to this circle here at this point. Point T is the point of tangents of tangent PT with this circle. So in this drawing, the following equation will be true. That PT square will be equal to PA times PB. Again, PT square equals to PA times PB. We can implement rule 10 in our drawing. Why? In our drawing, if you focus on the common extra point, point A, from the common extra point A, we have tangent AP, that is tangent to this circle here at point P. And we have here a chord TS that touches the extent that chord TS touches here at point A. After the extended chord TS, it touches point A. So all the requirements of rule 10 are satisfied, and therefore we can implement here rule 10. So according to rule 10, the following equation will be true. That AP square equals to AS times AT. Repeat again. If we focus on the common standpoint, point A, then according to rule 10, AP square equals to AS times AT. AP is A, therefore AP square is A square, so A square will be equal to AS. AS is 1 times AT. AT is 1 plus 3. In conclusion, we found out that A square equals to 1 times 1 plus 3, so A square equals to 1 plus 3 is 4, and 4 times 1 is 4, so A square equals to 4. Here we take a root out of this equation, and finally we get that A equals to the square root of 4, that is 2. So A equals to 2 units in its length, so I write it down in the drawing. Here A equals to 2 units in its length. Likewise, we will implement rule 10 at point in the common extra point C. So in the common extra point C, we have here tangent CQ, that is tangent to this circle here at point Q. We have ST, the extended ST, touches QC at point C. So all the requirements of rule 10 are satisfied, and therefore we can implement here rule 10, point C, and according to rule 10, we get that QC squared equals to CT times CS. Repeat again. According to rule 10, if you focus on the common sum point C, QC squared equals to CT times CS. QC is B, therefore QC squared is B squared, so B squared equals to CT. CT is 2 times square root of 3 times CS. CS equals to 3 plus 2 times square root of 3. So in conclusion, we actually found out that B squared equals to 2 times square root of 3 plus 3 times 2 times square root of 3. Here we'll open the brackets on this side of the equation, and we get that 2 times 3 times square root of 3 plus 2 times square root of 3 plus 2 times square root of 3 equals to 12. Why? Because 2 times 2 is 4, and square root of 3 times square root of 3 is 3, and 3 times 4 is 12. So in conclusion, I actually found out that B squared equals to 2 times square root of 3 times square root of 3 plus 12. Here we substitute 12 by 9 plus 3, and we get that B squared equals to 12. 12 is 9 plus 3 plus 2 times 3 times square root of 3. So this equation is very similar to the algebraic identity that states that A squared plus B squared plus 2 times A times B equals to A plus B squared. In our specific equation, A equals to 3 and B equals to square root of 3. And therefore, if A is 3, then A squared is 9 plus B squared. B is square root of 3, therefore B squared is square root of 3 squared, that is 3, so it is 9 plus 3 plus 2 times A is 3 and B is square root of 3. In conclusion, we found out that this expression is actually equals to A squared plus B squared plus 2 times AB. But according to this algebraic identity, A squared plus B squared plus 2 times AB equals to A plus B squared. That is to say, we can substitute our specific equation by A plus B squared. And A plus B squared in our specific equation, A is 3 and B is equal to 3. So A plus B will be equal to 3 plus 4 to 3 squared. Again, this expression 9 plus 3 plus 2 times square root of 3 times square root of 3 will be equal to 3 plus square root of 3 squared, according to the algebraic identity that A squared plus B squared plus 2 times A times B equals to A plus B squared. So this expression equals to 3 plus square root of 3 squared, and according to this equation, B squared equals to 9 plus 3 plus 2 times square root of plus 2 times 3 times square root of 3, and 9 plus 3 times 2 times 3 times square root of 3 is 3 plus square root of 3 squared. So in conclusion, found out actually that B squared equals to 3 plus square root of 3 squared. Here we take a root out of this equation, and finally we get that B equals to 3 plus square root of 3. So it is 3 plus square root of 3. Square root of 3 is 1.732, therefore 3 plus 1.732 equals to 4.732. In conclusion, we actually found out that B equals to 4.732. So you can write here in the drawing itself that B equals to 4.732. In the next step, we'll implement the Pythagoras theorem in this right big triangle, triangle ABC. So, in the right big triangle, triangle ABC, by PT is the abbreviation for Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. In the right triangle ABC, the hypotenuse is AC, therefore the square of the hypotenuse is AC squared. So AC squared must be equal to AB squared plus BC squared. Repeat again, according to the Pythagoras theorem, in the right triangle, triangle ABC, AC squared equals to AB squared plus BC squared. What is the length of AC? AC from the drawing is very easy to see that AC in total equals to 1 plus 3, that is 4, plus 2 times square root of 3. So in total AC equals to 4 plus 2 times square root of 3. And therefore AC squared equals to 4 plus 2 times square root of 3 squared. And it is equals to AB squared. AB equals to x plus 2, therefore AB squared is x plus 2 squared plus BC squared. BC equals to x plus 4.732, therefore BC squared equals to x plus 4.732 squared. In conclusion, we actually found out that, according to the Pythagoras theorem, 4 plus 2 times square root of 2, 4 plus 2 times square root of 3 squared equals to x plus 2 squared plus x plus 4.732 squared. So this expression, 4 plus 2 times square root of 3 squared equals to 55.7128, and it is equals to x plus 2 square. X plus 2 square equals to x square plus 2 square, that is 4, plus 2 times x times 2, that is 4x, plus x plus 4.732 square, that is equals to x square, plus 4.732 square is equals to 22.3918 plus 2 times x times 4.732, that is actually equals to 9.464x. So In total, we will find out that 59.7128 equals to, here we have x squared plus x squared is 2x squared plus 4 plus 22.3918 equals to 26.3918, and 4x plus 9.464x equals to 13.464x. Here we subtract from this equation 55.7128, and we get, so in this end of the equation we left with nothing, 0. This equals to 2x squared and 26.7918 minus 55.7128 is equals to minus 29.321 plus 13.464x. In conclusion, we found out actually that 2x squared minus 29.321 plus 13.464x equals to 0. Here we divide this equation by 2, and we get that x squared and 13.464, first of all, minus 29.321 over 2 is minus 14.66, and 13.464 over 2 is equals to 6.732x. In conclusion, we found out that x squared plus 6.732x minus 14.66 equals to 0. So this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula: x equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. In our specific quadratic equation, x squared plus 6.732x minus 14.66 equals to 0, the coefficient a equals to 1, the coefficient b equals to 6.732, and finally the coefficient c equals to minus 14.66. So in the next step we put the data for our specific quadratic equation in this general equation for x, and we find out the value or the values of x. I remind you that x is the radius of this circle. That is the radius that we are looking for. So we get that x equals to minus b. B is minus 6.732, therefore minus b is minus 6.732 plus minus square root of b squared. B is 6.732, therefore b squared is 6.732 square. That is actually 45.3198 minus 4 times a is 1, so minus 4 times 1 is minus 4, times c, that is minus 14.66, and minus 4 times minus 14.66 equals to 58.64 divided by 2a. A is 1, so 2 times a is 2 times 1, that is 2. So in conclusion, we actually found out that x equals to minus 6.732 plus minus. Inside the root we have 58.64 plus 45.3198 is equals to 103.9598 divided by 2. So inside the root we left only if 103.9596 and 98. So if we actually found out that x equals to minus 6.732 plus minus, and the square root of 103.9598 is equals to 10.196 divided by 2. So here we will have two solutions that are possible for x. The first solution will be negative because it is minus 6.732 minus 10.1998. It is a negative number, and because of the fact that x is a radius and the radius is a length must be a positive number, so the negative solution is the incorrect solution. So the only solution that is left, that is the positive solution. The positive solution for x is that x equals to minus 6.732 plus 10.196 divided by 2. So x equals to 10.196 minus 6.732 is equals to 3.464 divided by 2. So 3.464 over 2 is equals to 1.732. So in conclusion, we found out actually that x equals to 1.732 units. Repeat again. The radius of this circle x is equals to 1.732 units. So in the next step, I will summarize the lecture. In this lecture, we found out the radius of this circle. In the drawing, we have the right angle ABC, and this is angle ABC, that is the right angle, and we know that line segment AES equals to 1 unit in its length, line segment ST equals to 3 units in its length, this is like 70c, that is equal to 2 times square root of 3 units in its length. Inside this right angle ABC we have this circle, and our mission is to find out the radius of this circle. So first of all, we defined the radius of this circle, this point is O, and we define the radius, again we define the center of this circle, this point is O, and we define the radius of this circle, that is the radius that we are looking for, as X. Then we actually join points O and Q together by straight line. Point O is the center of the circle, point Q is the point on the circle itself, therefore OQ is the radius of this circle, that is equals to X according to our definition. We have the radius OQ that is known to point Q, that is the point of tendency of tangent BC with this circle. And whenever you have a radius that is known to the point of tendency, then tangent BC will be perpendicular to the radius QO. If BC is perpendicular to QO, it means that this angle equals to 90 degrees and this angle also equals to 90 degrees according to rule 1. Likewise, we join points O and P together by straight line. OP is the radius of this circle that is equal to X. And here we have the radius OP that is known to point P, that is the point of tendency of tangent AB with this circle. Whenever we have a radius that is known to the point of tendency, then tangent AB will be perpendicular to the radius PO. If AB is perpendicular to PO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. So inside quadrilateral OPBQ we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, plus the size of this fourth missing angle. In total, the sum of those 4 angles must be equal to 360 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, the missing fourth angle must be equal to 90 degrees in its size. So inside quadrilateral POBQ we have 4 right angles. Any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So we will relate to this quadrilateral POBQ as a rectangle. And we also know that the opposite sides of a rectangle are equal to each other. So in rectangle POBQ, side PO must be equal to the opposite side BQ. But PO equals to X, therefore BQ must be also equal to X. Likewise, in the same rectangle POBQ, side OQ must be equal to the opposite side PB, but OQ equals to X, therefore PB must be also equal to X. So we actually found out that quadrilateral POBQ is not a rectangle, but a square. Why? Because of the fact that all of its sides are equal to each other. Each side of this quadrilateral POBQ is equal to X, therefore quadrilateral POBQ is a square. In the next step, we defined the length of this line segment AP as X, and we define the length of this line segment QC as B. And we implemented the Pythagoras theorem, we implemented here rule 10. Repeat quickly on rule 10. Rule 10 is true in any circle. So in any circle, if we have chord AB, we have and we have also tangent PT that is tangent to this circle here at point T. Then in this moment, the following equation will be true, that PT square will be equal to PA times PB. Again, PT square will be equal to PA times PB. We can actually implement rule 10 in our drawing. While in our drawing, if we focus on the common standpoint point A, from the common standpoint point A, we have tangent AB that is tangent to this circle here at this point, point P. We have also chord TS that is extended until point A. So all the requirements of rule 10 are satisfied, and therefore we can implement here rule 10. According to rule 10, we get here that if we focus on point A, we get that AP square will be equal to AS times AT. Again, AP square equals to AS times AT. Repeat again. According to rule 10, if we focus on the common standpoint point A, the following equation will be true, that AP square will be equal to AS times AT. AP is 8, therefore AP square is A square, and it is equal to AS. AS is 1 times AT. AT is 1 plus 3. So in conclusion, we actually found out that A square equals to 1 times 1 plus 3. 1 plus 3 is 4, so A square equals to 4, we took a root of this equation and finally found out that A equals to 2 units in its length. This line segment Q3, this line segment AP is equal to A, it is equal to 2 units. Then we implemented rule 10 in this point on the common sum point C. On the common sum point C we have tangent CQ that is tangent to this circle here at point Q. And we also have the chord ST that is extended until point C. So all the requirements of rule 10 are satisfied, and therefore we can implement here rule 10. According to rule 10, CQ square will be equal to CT times CS. Again, CQ square equals to CT times CS. Okay, again, if you follow the common sum point C, according to rule 10, we get that QC square equals to CT times CS. QC is B, therefore QC square is B squared. It is equals to CT. CT is 2 times square root of 2, and CS is 3 plus 2 times square root of 3. So in conclusion, we found out actually that B square equals to 2 times square root of 3 times 3 plus 2 times square root of 3. Here we open the brackets on this side of the equation, and we found out actually that B square equals to 2 times square root of 3 times 3, and 2 times square root of 3 times 2 times square root of 3 equals to 12. So in conclusion, we found out actually that B square equals to 2 times 3 times square root of 3 plus 12. Here we substitute the 12 by 9 times 3, by 9 times 3, 9 plus 3 equals to 12. And we found out actually that B square equals to 9 plus 3 plus 2 times 3 times square root of 3. So this equation is very similar to the algebraic identity that A squared plus B squared plus 2 times A times B equals to A plus B squared. Here if we take in our specific equation A is 3 and B is a square root of 3, we get that A squared will be 3 squared, that is 9, plus B squared will be square root of 3 squared, that is 3, plus 2 times A, that is 3, times B, that is square root of 3. So 2 times AB will be equal to 2 times 3 times square root of 3. So this equation 9 plus 3 plus 2 times 3 times square root of 3 equals to A plus B squared. So, and A plus B squared equals to A is 3 and B is equal to 3. So A plus B squared equals to 3 plus square root of 3 squared. So in conclusion, we found out actually that 9 plus 3 plus 2 times 3 times square root of 3 equals to 3 plus square root of 3 squared. According to this algebraic identity, that A squared plus B squared plus 2 times A times B equals to A plus B squared. So we substitute this expression by 3 plus square root of 3 squared, and according to the equation, it is equals to B squared. So in conclusion, we found out actually that B squared equals to 3 plus square root of 3 squared. Here we took a root out of this equation, and finally found out that B equals to 3 plus square root of 3. 3 plus square root of 3 equals to 3 plus square root of 3. Square root of 3 is 1.732, therefore 3 plus 1.732 equals to 4.732. In conclusion, we found out actually that B equals to 4.732. So we can write down here in the original moment that B equals to 4.732. The next step, we implemented the Pythagoras theorem on this right big triangle ABC. So in the right triangle ABC, according to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is AC, therefore the square of the hypotenuse is AC square, so AC square equals to AB square plus BC square. Repeat again, according to the Pythagoras theorem in the right triangle ABC, AC square equals to AB square plus BC square. AC is 4 plus 2 times square root of 3, therefore AC square is 4 plus 2 times square root of 3 square, and it is equals to AB. AB is x plus 2, therefore AB square is x plus 2 square, plus BC square. BC is x plus 4.732, therefore BC square is x plus 4.732 square. So in conclusion, we actually found out that 4 plus 2 times square root of 3 square equals to x plus 2 square plus x plus 4.732 square. 4 plus 2 times square root of 3 squared in total equals to 55.7128, and it is equals to x plus 2 squared. X plus 2 squared equals to x squared plus 2 squared, that is 4, plus 2 times x times 2, that is 4x, plus x plus 4.732, that is equal to x squared, plus 4.732 squared, that is equal to 22.3918, plus 2 times x times 4.732, that is equal to 9.464x. So in conclusion, actually that 55.7128 equals to x squared plus x squared is 2x squared, 4 plus 22.3918 is 26.3918, and here we have 4x plus 9.464x equals to 14.464x. In conclusion, actually found that 55.7128 equals to 2x squared plus 26.3918 plus 13.464x. Here we subtracted 55.7128 from this equation, and finally found out that in this side of the equation we have nothing, that is 0. And the other side of the equation we have 2x squared and 26.3918 minus 55.7128 equals to minus 29.321 plus 13.464x. In conclusion, we actually found that the 2x squared minus 29.321 plus 13.464x equals to 0. Here we divided this quadratic equation by x, and finally found out that x squared equals to 29.321 over 2 is minus 14.66, and 13.464x over 2 is 6.732x. So in conclusion, we actually found out that x squared plus 6.732x minus 14.66 equals to 0. So this is the quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. This is the general formula. A, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula, that x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. In our specific quadratic equation, x squared plus 6.732x minus 14.66 equals to 0, the coefficient a equals to 1, the coefficient b equals to 6.732, and finally the coefficient c equals to minus 14.66. So we put the data inside this general formula for x, and we found out the value of the values of x. X is the radius of the circle. So we actually found out that x equals to minus b, b equals to 6.732, therefore minus b is minus 6.732, plus minus square root of b squared. B is 6.732, therefore b squared is 6.732 squared, that is 45.3198, minus 4 times a is 1, so minus 4 times 1 is minus 4, and minus 4 times c, that is minus 14.66. So minus 4 times minus 14.66 is 58.64. So inside the roots we have 45.3198 plus 58.64 divided by 2. And 45.3198 plus 58.64 equals to 103.9598. So in conclusion, we actually found out that x equals to 6.732 plus minus, side the root, we left only with 103.9598 divided by 2. And the square root of 103.9598 equals to 10.196. So in conclusion, we actually found out that x equals to minus 6.732 plus minus 10.196 over 2. So here we have two solutions that are possible for x. The first solution, x equals to minus 6.732 minus 10.196 is a negative solution, and x is a radius, and the radius is a length. So, length must be a positive number. So the negative solution is the incorrect solution. We cancel the negative solution and we left only with the positive solution for x. The positive solution for x is that x equals to 6.732 plus 10.196 over 2. And minus 6.732 plus 10.196 equals to 3.464. So in conclusion, we actually found out that x equals to 3.464 over 2, and 3.464 over 2 is 1.732. In conclusion, we actually found out that x, that is the length of the radius of this circle, it is equals to 1.732 units. Okay, thank you very much.